Hey everyone, welcome to our channel NCERT Science. So this video is a continuation of the NCERT Science Class 9 series that I am doing, and today we will be talking about Chapter 8 in NCERT Science, which is motion. So this is the first chapter in physics for this course, and up until now we talked about many chemistry and biology chapters. And before we start the lesson, I just want to go over my standard speech. Alright, so I want to mention three things before we start. The first thing is that this video will be helpful to those preparing for CBSE exams, NTSE, NEET, and JEE. We didn't include the JEE gang for biology because they didn't need it, but now welcome back JEE. Alright, so this will be helpful for all of you. And the second thing is that I will be presenting in my own words, and I have all these pictures taken from the NCERT official website that I found online, from the online textbook. So I encourage you to take your own notes, even though I am presenting in my own words. I want you to understand it and make sure you can note it down in your own words, because that will make it easier for you to remember things during the exam. Alright, the third thing is that I intend these videos to be under an hour and a half, because I want these to be videos that you can look at even the day before your exam for a revision or something. So if you feel I'm going fast, feel free to change your YouTube settings to 0.75 speed. Alright, so with that said, let's jump right in and start with Chapter 8, Motion. Alright. Okay, so like in every chapter, all this is a basic introduction and an overview of what's going to happen in the lesson. And before we start with the actual lesson, I want us to do like this small activity. Alright, I want you to pause this video after I give you the instructions. I want you to pause the video and make sure you write down a few concepts of physics. Like it could be force or gravitation or anything that you ever heard of. Make sure you write down those names, and if possible, write down the formulas for a few quantities as well. Alright, so pause the video right now and hit play again once you're done with that. Alright, welcome back. I just want to I did this activity with y'all because that's how my teacher introduced class 9 physics to us, and it was fun. I felt it was fun, so I just wanted to see if all of you found that fun. Hopefully you found that fun. Alright, so some of the common topics that you might have noted down are force, gravitation, pressure, motion, right, because that's the name of the chapter, right, and many more. Everyone thinks differently, so you do not need to have just these four. You do not need to have any one of these if you have other valid physics concepts. Alright, so I hope you found that activity fun. Let's start with the lesson. So we are going to start with describing motion. So when we describe the location of an object we specify a reference point. So think of it like this. Your friend is trying to come over to your house for some party, let's say, and you are trying to give your friend directions to your house. Alright, so you're going to say, hey, call me after reaching this particular point and I will be able to give you directions to my house, because no one expects you to be able to give accurate directions from your friend's house to your house. So you're going to say maybe like, there's this famous bakery near my house, or there's this famous shop near my house that you can reach, and you can call me after you reach there so I can give you accurate directions, like go straight, take the second right, or something like that, right? So imagine that scenario. So the reference point in that would be that famous landmark or that shop that makes it easier for you to give directions to your friend, right? So the railway station, in this case the famous shop, is the reference point, and we could have chosen any other reference points according to our convenience. So maybe there's an even famous restaurant near your house. You could have chosen that for your convenience, but uh, whatever is more convenient to you, you can choose that. There's no rule that you have to choose only this landmark or this reference point. All right. So to describe the position of an object, we need to specify a reference point, and that reference point is known as the origin. All right. So motion along a straight line is one type of motion. So imagine there is a shop, that same shop that we were talking about. Let me switch colors. So nope. So alright, so this is the shop. I'm doing it in red. I'm going to say shop, and this is your house. Alright, so I'm going to draw a door in a traditional house of sorts. Alright, so let's say there's a straight road. There's just one straight road between the shop and the house. Don't know why that's happening. Alright, so let's just say there is one straight road from the shop to your house. Alright, so the simplest type of motion would be the motion along a straight line. Now let's say instead of here, the shop was here. Alright, so you might have had to tell your friend to reach your house from this shop, go straight, take a right, take a left and go straight, take a left again and go straight, and then take another left and then go straight. You'll have my house. That is a very complicated thing, at least relative to this motion in a straight line. This is complicated, right? So motion in a straight line is the simplest type of motion, alright, because it's just one straight line. Alright, so even when you're giving directions to a particular thing in your house, it's easier for you to describe that place if it's in a straight line from where you are or from where the other person is, instead of saying go right to the second room on your left, on the second cupboard to your right. All of that makes it a little more complicated, right? That's how it is, and that is why we can say that motion in a straight line is the simplest type of motion. Alright, so once we consider the motion of an object here, there is O, the origin point, and then there's A, B, and C points here. Alright, so essentially in this example, it says that we travel from O to A and then back from A to C. Alright, so we traveled like that, and then we came back to C through A and B. So we moved from O to A through B and C, and then we moved back to C from A by passing through B. Alright, so in this scenario, the total path length would be the length of the paths that you took, right? So that would be OA plus AC, because it's the total path length, right? So the total path length also happens to be distance. So the basic definition of distance is the total path length covered by an object, irrespective of the direction of motion. Alright, so that is the basic definition of distance. The key terms would be total path length and irrespective of the direction of motion. Alright, so the shortest distance measured from the shortest distance between O and C, if we want to calculate that, so the shortest distance would be just OC, because you're starting from O, and you're starting at O and you're ending at C, right? So what's the shortest distance between the initial and final points? OC. But if you want to find the total path length, it would be OA plus AC. Alright, so just as how the path length is distance, the shortest distance would be displacement. Alright, so displacement is the shortest distance measured from the initial to the final position of an object. Alright, that is the basic definition of displacement. So shortest distance and measured from initial to final position, they are the key terms here. Alright, so we have a question here. Can the magnitude of displacement be equal to the distance traveled by an object? So one simple and short answer is sometimes. Alright, so sometimes the magnitude of displacement can be equal to the distance traveled, and notice that I stated this part twice until now, and both the times I stressed on the magnitude, right? That is very important because displacement is do not know why that keeps happening. Alright, displacement is displacement measures the direction of motion, while distance does not depend on the direction of motion, right? So here there was this concept that talked about scalar and vector quantities. Scalar quantities are the quantities that do not measure the direction. It's only the numerical value, and examples of those would be distance, speed, right? Alright, and then there's vector quantities, which are the opposite of scalar quantities. They measure numerical value plus direction of motion. Alright, so examples of those would be displacement, velocity, acceleration, and so on and so forth. Alright, so magnitude of displacement would be in a mathematical sense the absolute value of displacement. Alright, so I'm sure you guys are familiar with these symbols that I used here. That's the modulus, or the absolute value, irrespective of whether the value within these symbols is positive or negative, the answer would turn out to be positive, right? So the magnitude of displacement would be, when would the magnitude of displacement be equal to the distance? Alright, that is the question. So there are three cases typically, alright, and of those three cases there is only one situation in which the magnitude of displacement is equal to the distance traveled. Alright, so imagine there is a point A, which is your initial position, and point B, which is your final position. Alright, so imagine that you're talking about a city here, and there are three roads from A to B. The first one is somewhat like that. Alright, the second one, let me do it another color. The second one goes like that, and the third one is directly from A to B. Alright, okay, so they look similar, so let me do that. Alright, so here this would be path. Let's assume that this is path 1, this is path 2, this is path 3. Alright, so here the distance is the total path length here, right? So this is the distance, In here is just this one straight line, so this is also the distance, and here it is this curved line, that is also the distance. So d1, d2, d3. But in this case, the displacement would happen to be equal to d2, right? Because it's one straight line, and the shortest distance between the initial and final positions, which happens to be distance the second way, which is d2, is the displacement. So in cases 1 and 3, distance 1 and distance 3, they're both greater than displacement. Displacement is represented by an s usually. Alright, so distance 1 and distance 3 are greater than displacement, and distance 2, which happens to be the second situation, is equal to displacement. Alright, so there is, if you observe this carefully, and if you think about the definition of the basic definition of displacement, you will be able to draw one conclusion, that distance is always greater than or equal to displacement. Alright, it is never, I need to stress on this. Alright, I need to do capital letters for us. Never less than displacement. Alright, distance can never be less than displacement, because according to the basic definition of displacement, it is the shortest distance measured between the initial and final positions. If displacement is the shortest possible distance, how can there be a value of distance which is less than displacement, right? So if you think along those lines, you can come to a conclusion that distance is always greater than or equal to displacement, but it is never less than displacement. Alright, so we have two activities here that I'm sure you can do on your own, and then we have 3 questions that cover the content that we discussed so far. Alright, and if you have any difficulty answering one of the questions, feel free to go back to that part of the video where I explained the lesson. Alright, so we start uniform and non-uniform motion now. So let's consider an object that is moving along a straight line, and before we go any further, I just want to define uniform motion here. Uniform motion is that type of motion in which an object covers equal distances in equal intervals of time. Alright, equal distances in equal intervals of time, that would be uniform motion. So equal distances and equal intervals of time, those are the key points. Alright, okay, and then moving on, we have non-uniform motion. So before I write down the definition of non-uniform motion, because it can be a little confusing if I write it at once, the definition of non-uniform motion, there are 2 actually. Alright, the first one is the type of motion in which an object covers equal distances in unequal intervals of time, and the second one would be the type of motion in which an object covers unequal distances in equal intervals of time. Alright, so either the distance or the time interval should be unequal. Alright, so I am going to put unequal here with brackets unequal distances in equal intervals of time, or alright, so or equal distances in unequal intervals of time. Alright, so one of these should be unequal, whether it's distances or time intervals is up to you. Personally, I got used to saying non-uniform motion is that kind of a motion in which an object covers equal distances in unequal intervals of time, but it's totally up to you, whatever you are comfortable with, go for it, alright? Alright. Alright, so then we have this statement: different objects may take different amounts of time to cover a given distance. Alright, so to make sense of this sentence here, I want us to imagine a situation. Assume that you are going from your house to your school, that you have to travel from your house to your school, and you have three options with you. You can either walk, or use your bicycle, or you can use a car or a two-wheeler or whatever to drive from your house to your school. Alright, so there are three ways, and these are three different objects, but the distance between your house and your school does not change whether you're walking or driving or cycling. The distance between your house and your school is constant, but the amount of time that you take to reach school when you use these three ways of commute differs, right? Because you might take longer if you're walking, while you're walking, than when you're driving, and you might take relatively less time if you're cycling than the time you took when you're walking, but that is still going to be less than the time that, more than the time that you are going to take if you're going to drive. And if you're driving from your house to your school, then you will take the least amount of time. Then you're more likely to take the least amount of time. I can't say if there's like a very bad traffic jam, it's easier for you to walk, but you're most likely to spend the least time reaching your school from your house if you drive, right? So that is, if you connect with the situations like that, you will make sense of these situations and sentences a little better. So different objects may take different amounts of time to cover a given distance, and and the rate at which objects move can be different. Alright. Also, different objects can move at the same rate. So if you're talking about two people who are walking, they can move at the same rate, but they're different objects, right? They're two different people, they're different objects, but they can move at the same speed, at the same rate. They're more likely to be able to move at the same rate. Alright, so the quantity in the quantity that measures the rate of motion of an object is speed. So speed is defined as the rate of the rate at which an object covers a distance in unit time. Alright, so I'm sorry about that. Okay, so speed is a quantity that measures the rate at which an object covers a given distance in unit time. Alright, so the SI unit of speed is meters per second. Why is that? Because speed measures the distance per unit time, right? The SI unit of distance would be meters, the SI unit of time would be seconds. So the SI unit of speed is meters per second. You can see meter per second as this, or it's most likely m times s to the power -1. That's what you'll most likely see in textbooks. Alright, so once we're done with that, let me clear that because it'll be easier for you and less cumbersome. Alright, okay, so SI unit is not the only unit of speed of any quantity, and all of us know that. So what are the other units? It could be kilometers per hour, it could be centimeters per second, it could be millimeters per second, it could be kilometers per minute, it could be meters per minute. It can be it can be any combination of two units, and one of these two units should be a unit of distance, while the other should be a unit of time. All right, whether it's minutes, seconds, hours, or days, weeks, doesn't matter. As long as when you're solving numericals, you have all these quantities converted to the same units, you should be very fine. All right. So what's the average speed when you're given different quantities of speeds and when you're given different times? How do you calculate the average speed? Average speed is given by total distance by total time. Alright, so if an object travels a distance s in time t, then speed v is equal to s by t, and we're used to saying s is equal to d by t, speed is equal to distance by time, but this is the proper way of saying it. Alright, v is equal to s by t. We have an example here that says an object travels 16 meters in 4 seconds and then another 16 meters in 2 seconds. What's the average speed of the object? So here we have total distance as being equal to 16 of over here and 16, another 16 over here. So 16 plus 16 is equal to 32 meters, and total time is 4 seconds plus 2 seconds, which would be 6 seconds. Alright, so average speed, for those of you who are writing your CBSE exams, you have to mention the formula, and that carries points for itself. So average speed is equal to total distance by total time. Alright, so that will be a step in itself, which is going to be equal to 32 by 6, which is 5.3 bar, right? So it would be 5.333 non-recurring. Alright, so 5.3, that's 5. I don't want people to get confused with it for 6. That's 5.3 meter per second. Units are very, very important in physics, in math, in chemistry. Units are very important. Alright, they are very important. They carry many units are the places where most students lose marks when they don't mean to lose marks. Alright. So, speed with direction. The rate of motion of an object can be comprehensive if we specify its direction of motion along with its speed. So, think of this comparison. I say distance is to speed is as what is to speed with direction. Alright. So distance is to what? So distance as a speed is as what is to speed with direction. The answer for this would be distance with direction, right? Because we're just adding with direction for both of them essentially, right? So distance with direction has a name. We learned about that. That would be displacement. Similarly, speed with direction also has a name, and that is velocity. Alright, so if speed measures distance, velocity measures displacement. So speed, the definition of speed would be a measurement, a quantity that measures the rate at which an object covers a specific distance in unit time. Velocity would be displacement instead of distance. Alright, so for velocity, the average velocity is not similar to average speed. Alright, average speed was total distance by total time taken. Average velocity will be initial velocity plus final velocity by 2. Alright, So initial plus final by 2, that would be average velocity, and mathematically it would be v sub av, which stands for average, equals u plus v by 2, and u is initial velocity, v is final velocity, and average velocity would be v sub av. Alright, so the speed, the units of speed and velocity are the same, and it's meters per second. Alright, and we have another activity here that you can do on your own. We have another activity, and we have 5 questions that I want you to try on your own and see if you can do them. If you're stuck on any problem, feel free to go back to the part of the video where I explained it. So now we have a numerical here. The odometer of a car reads 2000 kilometers at the start of the trip and 2400 kilometers at the end of the trip. If the total trip took 8 hours, calculate the average speed of the car in kilometers per hour and meters per second. So converting from kilometers per hour into meters per second would be x kilometers per hour into 5 by 18. Alright, and that would give you y meters per second. Okay, and instead of remembering 5 by 18 and getting confused with whether you want to use 5 by 18 or 18 by 5, I want, if you're typically that kind of person who forgets things like that, I do that. Alright, so I understand what you're going through. Alright, so how I remember it is kilometers per hour into 1000 meters for every kilometer. Let me not do per hour as ph. Alright, so no, wait. So x kilometers per 1 hour, right? So 1 kilometer would be 100 meter, 1000 meters, into 1 hour would be 3600 seconds. Alright, so you should be able to cancel out kilometers and kilometers, 1 hour and 1 hour. Alright, so you're left with x times 1000 meters by 3600 seconds. That will be equal to x times 5 by 18, because when you simplify it, this will be 2 5s, so 2 18s. Alright, 5 by 18 meters per second. Alright, so x is that x is the kilometer per hour speed, and y would be your answer, which is in meters per second. Alright, that's one way, a very easy way of remembering it. If you know what you're looking for and how you came to that conclusion, you don't need to memorize as many things as you would if you don't remember or if you don't know why that's happening in the first place. Alright, so now that we know how to convert from kilometers per hour into meters per second, let's calculate the speed in kilometers per hour. So this is the final distance, this is the initial distance. So total distance would be initial distance final distance minus total distance. So let me do distance is equal to 400 kilometers, time is equal to 8 hours. So speed is equal to distance by time, which would be 400 by 8, which would be 50 kilometers per hour. That is part 1. Part 2, 50 kilometers per hour into 5 by 18. So 5 by 18, that would be the speed in meters per second. Alright, that turns out to be 13.9 meters per second. And then we have another example numerical that I want you to try on your own. Now let's talk about rate of change in velocity. Alright, so during uniform motion of an object along a straight line, the velocity remains constant with time. Alright, and in this case, the change in velocity of the object for any time interval is 0. However, with non-uniform motion, velocity varies with time and it has different values at different instants and at different points in the path. So that's why the change in velocity of the object during any time interval is not 0. Alright, and when is that? For non-uniform motion. Alright, so how can we express the change of velocity in an object that's moving with non-uniform motion? We talk about acceleration. Alright, acceleration is another topic, is another concept that measures the change in velocity along a given time interval. Alright, so acceleration would be change in velocity by time taken. Acceleration would be equal to change in velocity can be determined by delta v by delta t, and delta v would be final velocity minus initial velocity, which is v minus u. So acceleration is v minus u by t. Alright, so the SI unit of acceleration would be meters per second square. Alright, and why is that? Because meters per second is the unit for velocity and second is the unit for speed, for time, right? So your math skills should kick in right now. Alright, meters per second would be meters per second square. Loss of exponents, this would be -1 minus 1 if you take this power to the numerator, so it will be -2. Alright, so that kind of motion is the accelerated motion, and acceleration is positive if it is in the direction of the velocity, and if acceleration is in a direction that is opposite to the direction of velocity, the sign for acceleration would be negative. Alright, so the motion of a freely falling body is uniformly accelerated motion, and the motion of a car traveling along a straight road is an example of a non-uniform acceleration motion. Alright, we have another activity here and we have another numerical here that I want you to try on your own. We also have 3 questions that I want you to try on your own. And now we are talking about graphical representation of motion. Graphs in physics. Yay. Right? Alright. So graphs are basically just this simple representation of complex ideas, what's happening around us that's very complicated, and graphs make it simple for us to understand and visualize them. Alright, just a moment. Okay, I just wanted to drink water. Okay, so there are 3 types of graphs. The first one would be distance time graphs. No, I'm doing it with the eraser. The first one would be distance time graphs. The second one would be velocity time graphs, and the third one would be position time graph. Alright, so dt, vt, pt. Alright, so distance time graphs have distance along the y-axis and time along the x-axis. Velocity time graphs have velocity along the x-axis and velocity along the y-axis and time along the x-axis. Position time graphs have position along the y-axis and time along the x-axis. Alright, so this figure that you see here is a distance time graph, 8.4, figure 8.4. So we see that it's a straight straight line which is slanted upwards and it's moving upwards. So it tells three things about this. It tells two things about this motion. First of all, the straight line shows that it is moving with uniform speed, not uniform velocity, but uniform speed. Alright, and the second thing is that it's moving with positive uniform speed, as in it's increasing its speed uniformly. It's not decreasing its speed uniformly, it's increasing its speed uniformly. Alright, so this graph shows that the distance traveled by the object. I don't know what's wrong with this. Alright, the distance traveled by an object is directly proportional to the time taken. So for uniform speed, a graph of distance traveled against time is a straight line. Alright, and why is it a straight line? Because it's moving, it's increasing or decreasing. In this case increasing, but there are cases where it's decreasing also. It's increasing or decreasing by a constant rate per unit time, right? That is why. Alright, so now on this graph we have points O, A and B. So let's say the coordinates for B are S2, S1. No. So the x coordinate is time. So y2, x2, and for A it is y1, x1. Alright. So how do you find the speed of this line? You would find the distance between, you would find the slope of the line here. You would find how much the line is inclined. So to do that, you will have to subtract these coordinates. So subtracting these coordinates, you would get y2 minus y1 is equal by x2 minus x1, and you will be able to notice that this is also the definition for slope in mathematics. So this can help us prove that the speed of an object in its distance time graph can be found by using the slope of that graph. Alright, so then moving on, we have the distance time graph of a car moving with non-uniform speed. So if that previous car was moving with a uniform speed that was like so, now it's moving with uniform speed that is not straight, that's not parallel to this the red line. The blue line is not parallel to the red line, and that shows us that the blue line is not moving in uniform speed like the red line, but the blue line is moving in non-uniform speed. Alright, so that's the distance time graph for an object moving with non-uniform speed. Then we have velocity time graphs, which talk about the variation of velocity per time. Alright, so here we have points A, B, C and D marked. Alright, so let's just assume that AC is the change in velocity and CD is the change in time. Alright, so how do you find the distance that is moved by the car in time t? Alright, which is 4 minus 1, which is 3, but we are able to say this because we have the values clearly given. If the values are not given and we're supposed to find out the formula and solve it by ourselves, this is the procedure that you're supposed to use. Alright, so AC is the change in velocity and CD is the change in time. So to find the speed, we would have to find the area of this rectangle. Alright, How do you find the area of a rectangle? Length times breadth, right? So the length would be AC and the breadth would be CD. That is the speed. Speed equals 8C times CD. Alright. So moving to the next question, to the next page. We have the velocity time graph for a car that's moving with uniform acceleration, and the distance for this graph can also be found by using the area, and they made it easier for us to find the area by already turning it into two different shapes, right? So we can first find the area of this triangle by using the half times breadth times height formula, and then you can find the area of this square here by using the s square formula. Alright, so the sum of the areas of this triangle and the square would give you the distance that was covered by the object. Alright, so the sum of the square plus the sum of the areas of the square and the triangle would give you the distance covered. Alright, and in figure 8.7, both these graphs are also velocity time graphs, but they are the graphs for objects that are moving with non-uniform acceleration. Alright, so now we have another activity that I want you to try, and we have 4 questions, and we have the equations of motion, finally. Alright, so there are 3 equations of motion. All 3 of them are very important. The first one is V is equal to U plus AT. The second one is S is equal to UT plus half AT square. And the third one is 2AS is equal to V square minus U square. So giving all the definitions in word form, with V being equal to the final velocity, U being equal to the initial velocity, A being equal to the acceleration, T being equal to the time taken, and S being equal to the distance or the displacement. So I just explained whatever each symbol means, alright? So that was the first part of the sentence. Now the second part of the sentence would be the formulas that I'm trying to represent verbally, alright? So the first equation of motion says final velocity is equal to the sum of initial velocity and the product of acceleration with time, alright? So the second one says the distance covered by an object is equal to the sum of 2 products, the first product being initial velocity multiplied with time, and the second product being half times the acceleration multiplied by the time squared. Alright, the third equation would be 2 times the product of acceleration and the distance covered is equal to the difference between the squares of the final and initial velocities. Alright, so the next 2 or 3 pages, I believe, they're all explanations on how the different equations of motion were derived based on graphs. I do not wish to go through them because it's a CBSE only topic that's only going to be covered in CBSE exams, and I am not sure if they still do it. They stopped doing it when I was doing. They were thinking of stopping to do it when I was doing 9th grade. I'm not sure if you guys still do it. The derivations for CBSE exams might be important, but for NTSE, NEET and JEE they are not important, so I'm going to skip through them. And we have a few examples here that I want you to try on your own, alright? And we have a few questions. When you're trying to solve example 8.6, keep in mind that you are supposed to convert the units, alright? That is very important, or you'll end up getting the wrong answer. So now we have uniform circular motion. Alright, so whenever you're moving from one place to another, there are multiple ways of moving. If A is here and B is here, you could either move like this, or you could move like this, or you could move like that, or in any random way. You're basically going to travel from A to B. Doesn't matter how you do it, but the red line is the shortest distance, which is known as the displacement. There are also some situations where A and B are the same. So in order to go from A to B, you'll just take a round and you're back to B from A, or back to A from B, whatever, however you want to see it. Alright, so uniform circular motion is what we're going to talk about now. When the velocity of an object changes, we say that the object is accelerating, whether it's positive acceleration or negative acceleration. It depends on how the velocity of the object is changing, but in general we say if the velocity is changing, the bodies or the object is accelerating. The change in the velocity could be due to three reasons. Either it could be because of a change in magnitude, or because of a change in the direction of motion, or because of both. Alright, so when we think about the example of an object, when we think of an example of an object that does not change its magnitude or velocity but only its direction, the answer would be objects that move with uniform circular motion. Alright, so how do you find the velocity when an object is moving in uniform circular motion, or the speed of the object? So speed or velocity, the formula for speed would be, or for velocity, let's take it for velocity. Velocity is displacement by time. Displacement is the essentially just distance, as long as you're not having a situation where the initial point is equal to the final point, in which case the displacement would be 0. Alright, so displacement, also known as distance. Alright, so distance of a square, distance of a circular path would be given by its circumference. Yes, circumference, and the formula for circumference is 2 pi r, right? So 2 pi r by t would give the velocity of a body moving with uniform circular motion. Alright, so there are many applications of uniform circular motion. One thing that the textbook mentioned, and one thing that I like to talk about, is shot put, in which the athletes usually, and they typically turn a whole circle or more before they release the shot put into the sand, right? While a part of it may be because of momentum, another part is because whenever you move an object along a circular path and you release that object at some point, the path of the object taken would be tangential, like if you're talking about math terms now, right? If we have a, nope, yep, I meant to erase it. Okay, if we have a circle here, at this point here, a tangent could be drawn, right? What's a tangent? It's just a straight line that can be drawn through a point, right? So at this point that I mentioned in green, a straight line could be drawn like so, or like so, right? So the object, when released after moving along a circular path, would travel in a direction that is tangential to the point at which it was released. So shot put athletes usually tend to leave the ball at such a point that the object will fall farthest away from the person, because they want to win, right? That is an application of uniform circular motion. And you know, whenever we apply stuff like physics concepts to real life examples and real life situations, I felt that two things would happen. Alright, so the first thing is that we're so fascinated by physics and how it influences the world around us in every single way possible that we start studying more about them and being more fascinated. The second thing is that we're just too tired of seeing physics everywhere, even in daily activities, so much so that we don't, you know, we don't think of daily activities without having to think, oh, this is the reason, the scientific reason behind the this activity happening, right? And that's, to an extent, that shows how successful you are in your learning, because you're able to apply what you're learning to your surroundings, which is the whole point of education, right? So you're supposed to be happy if that happens. You're supposed to be proud of yourself for having learned what you were actually supposed to learn, having fulfilled the purpose of your education, so to speak, right? So if you find yourself applying these concepts to daily experiences, you are very close to success. Alright, so with that, on that positive and optimistic note, I am going to tell you that this lesson is over, and we have what you have learned points that are good for going through the night before your exam or the day of your exam. And we have a few activities, exercises that I want you to try once you are confident that you understood the concept and the lesson well. Alright, and now it's time for points to recap. So throughout the lesson, throughout this video, this is what we did. We did 8 things that I could think of, right? So first we introduced the topic by I introduced the topic by asking all of us to pause the video and write down a few physics concepts, right? That was the first thing that we did. The second thing is that we talked about motion along a straight line, and that's the simplest type of motion. And then we talked about uniform and non-uniform motion. And then we talked about speed and velocity, the difference between speed and velocity, the difference between distance and displacement. We talked about graphs, distance time graphs, velocity time graphs, and position time graphs. Alright, and then we went over the equations of motion and the numericals. I asked you to look through the derivations if that's going to help you remember the formula better, whether irrespective of whether you're studying for NEET, NTSE, JEE or CBSE boards. Go for it. If you're studying for CBSE exams only, you are most definitely going to have to watch the derivations, because I'm 90% sure they still test you on that. Alright, and then we talked about uniform circular motion and how athletes playing shot put use them. And when we talked about, and we just went through the 2 pages that covered the exercises, and with that we finished the chapter motion. Alright, so I hope this you found this video helpful, and I hope it helped you understand the concept better. Head on to the next video, which will cover chapter 9 in physics for NCERT Science class 9, which is force and laws of motion. Don't forget that you can do this, and have a great rest of your day. Do not forget to like and share this video, subscribe to our channel for more content, and rock your exam. All the very best. Bye bye.